The user-defined operating picture provides a variety of functionality for users. Starting in the left of my screen, you see the Views tab that allows users the view of different layers of data via a set of thematic folders. There is a Fly To feature for users to jump to a specific spot on the globe that is displayed here on my right. This display on the right is the Google Earth plugin, and users can manipulate data in this view with tools throughout the rest of the UDOP. At the bottom, there's information about the creator of the layer, the individual that approved the layer for public display, and the options to edit, remove, or unapprove the layer. Also here, a user can download the KML file of the data if they want to share it with others. Users can simply select the layers they're interested in by clicking on them. Clicking through the layers here, you'll see the ability to control things such as the terrain layer, the sun, and the atmosphere, just to name a few. These layers can be organized in a variety of ways. The UDOP tools and the data connected to them are built on a framework called iSpatial that wraps around the Google Earth browser plugin. iSpatial allows many data feeds to stream into UDOP and provides a platform for additional tools to be developed on so users can interact with their data. I can manipulate the globe in the same way that I would any Google Earth client. I can fly through it and dive into underwater views and see a variety of features. I might add a wrecked ship here or other data in this view. This provides the ability to truly interact with all of the elements of my environment, even if they are below sea level. The value of having the work of many individuals aggregated in this one view is extremely powerful, and the sheer amount of data available through the UDOP has endless possibilities. One of the nice features of UDOP is that it works in whatever browser you're using. I'll switch from Chrome to Firefox to show you the same capability. This instance of UDOP I'm currently working on is pointed towards a privately managed globe with slightly different imagery than you would see in the public globe. You may want your own globe for a variety of reasons, particularly if you have security constraints on using an open network for your information. Within the Tools tab, users can upload KMLs and post them on UDOP. They can also add dynamic KML or KMZ files that are updated elsewhere on the web. The iHarvest tool provides a unique capability to find similar users, access alerts, review recommended layers, and view the breadth of content creators that develop the layers they are currently viewing. Users' activity within the UDOP is modeled based off of the layers they interact with and the spatial area that they are viewing. This gives a foundational level of data for iHarvest to analyze in order to connect users with other individuals that might share common interests, and then alerts them when new information is presented to UDOP they might want to see. There are additional tools for converting coordinates to different formats and for capturing a link of the view you're looking at so you can share it with others or refer back to it in the future. Users can launch the presentation builder and load views of the areas they're interested in, as well as other layers. They have a small widget that allows for them to control the presentation, add views, go forward and backward, etc. Here we'll start with a view of various routes that were prepared for a U.S. humanitarian mission while in Haiti. The presentation control panel can be moved around the screen, and a full screen mode can be activated to display more detail of the area being discussed. In this presentation, you can see various gang-controlled areas depicted in the upper left with red polygons, and you see the primary routes that were being used on the mission. Users can create tours as well and simply launch them while they talk to what is going on. This tour depicts information on looting and damaged buildings that may cause interference for the individuals traversing the route. Alternate routes are indicated to provide options if the primary route is unsurpassable. So here in the full screen mode, you have a better view of the entire globe and can see the detailed imagery that is available for presentation. This background globe can access Google's public globe, or you can house your own internal imagery to show whatever level of secure data you'd like on any of your networks. I can select another view here by simply clicking Next or selecting the scene I want to talk to. Leaving the full screen mode, I will take a second to show you the content creation tools that iSpatial provides. Users can create new layers and update them as things change in their environment. Let's set up a water treatment and distribution site here on this staging area. First thing I'm going to do is create a few icons to indicate where my distribution points are. We'll label what we're creating, and we'll use the symbology that is available in order to stay within the international codes agreed to for everyone supporting this relief effort. We'll stretch a polygon now around the area so others know that this entire location is set up for water distribution. Finally, we'll draw an entrance path and an exit path so organizations coming to fill up know how to plan their route into the area without getting congested. All icons and line colors are configurable based on the organization leading the effort and can be rotated depending on who is using the system. Information such as date and description, as well as my personal information as the creator, is captured in order to provide a pedigree for others to reference in the future. Once we have all of the data for this layer input, we review our work and then we go to Current Content and select Save All to store this KML so it is shared with others and available for future review and editing. As we move along through the presentation, we see the ability to display pictures captured from the mobile application that was developed in conjunction with UDOP. Here you can see how someone took their mobile device and snapped a picture of a culvert along a main route. The detail is obvious, and the degree of information this adds to the big picture is evidenced as I move around the image. Another view shows the 3D nature of UDOP with a model of the damaged Haitian palace and pictures taken around it. These 3D models can easily be created through Google SketchUp and then added to UDOP as a KML. Moving south, we see another model of a local stadium. We have more pictures embedded to show additional detail about the area around this stadium. The stadium provides a view of both imagery, showing tents going up, as well as the damage to its overall structure. Street View is another really cool capability that shows a 360-degree view of areas along the streets. We were able to collect approximately 300 miles of streets in this view. Users can pan around as well as look up and down in this street view to get a really good idea of all of the information on the street in that view. Exiting Street View, we'll move to another site. Conducting analysis of the fused information is really one of the key features of UDOP. Here we have a floodplain image layered over our globe, and we have selected an IDP camp layer to see which camps might be in potential flood areas. We can select the camps and see metrics about each camp as we plan to relocate its inhabitants before the rainy season. By leveraging this existing data, then mashing it together for different analysis, we can plan much more effectively for various real-world problems that are affecting our relief efforts. Another UDOP capability is to add images such as LiDAR. We can layer them over the exact spatial area that they cover. Here you see images of a bridge that allows us to analyze the amount of traffic it is receiving and how much damage it might have sustained. Multiple images of the same area can be added at different altitudes to compare and contrast the changes. Continuing through our presentation, we now turn on a variety of dynamic data layers. We can animate these and see things such as how the weather is changing. We can pull data from authoritative sources and see how new earthquakes are affecting the region we are looking at, or how potential flooding may impact an area. Going back to some of the key tools within UDOP, I'll show you a very cool capability in the Sharing tab. Here, users have the ability to share the same view that someone they are working with has. One user can select to share their view and creates a password to control who sees what they're working on. As you can see, I have two browsers launched and they are very distinct sessions. The user that wants to view the session selects their Sharing tab in order to view the activity of the other user. I'll click on the user's name that I want to watch and I enter the password for the session. The view will share across both screens and users can interact with the data simultaneously. The primary user's view will be displayed on the screen of the user that's watching. The session can be paused and both users can turn data on and off in their view to gain information about what they're looking at. Sharing can be turned off when the collaborative session is over. Many layers can be turned on and off depending upon the data that a user is interested in viewing. Key logistics information can be updated by individuals on the ground that are working on each cluster. Then, decision makers or others supporting the relief effort can see in real time what the updates are. Here you see we have a hospital, some wells, and an embassy selected. There is a variety of wells up by the airport. Information about each well is available by clicking on the icon. You have everything from videos to text, and here you can see pictures even attached to the well that gives you more detail about what you're looking at. We can continue to move around our globe and see other data, like the pictures that were sent from mobile devices in the area. Simply zooming into the picture immerses you in the detail of what is occurring on the ground. This concludes a very brief overview of just some of the capabilities available in UDOP with iSpatial. Many more features are being developed for a variety of different needs, and we really think that the sky is the limit on what we can do with this capability.